Hi, everybody, and welcome to the Infrastructure as Code podcast. We're going to talk about cloud and specifically about infrastructure as code. You can follow up on Twitter, the IaC Podcast. You can follow me directly, DevOps Ohad. My name is Ohad Meislish, and I'm going to be the host for today. And today we have an amazing guest. We have Hassan, the CEO and co-founder of InfraCost. Hassan, welcome.
Thank you so much for having me.
It's our pleasure. Tell to our audience who you are, please.
Sure. So, hey everyone, I'm Hassan. I'm one of the co-founders of InfraCost. I've been involved in cloud and especially around cloud costs since 2011, I think now. So it's been a while, and seen many iterations of infrastructure as code, and cloud costs through that period of time.
Awesome. And can you tell us more about InfraCost for those who are still not aware of this amazing open source and company?
Sure. So I'll give a quick background and then I'll tell you where InfraCost is. So like the usually way that cloud costs are being managed has always been after the fact, right? You provision infrastructure, it goes to production, it starts incurring costs. And then afterwards, someone gets a bill and they're like, whoa, why is it so high? Where did this come from? The shock, right?
The cloud bill shock, yeah.
Everyone loves that shock. And then kind of with InfraCost, and one of the things that I think IaC has really enabled is we can be proactive about cloud costs, for example. So what InfraCost does is sit in the CI/CD pipeline, and anytime someone changes infrastructure, it tells the DevOps engineer or the end user, hey, this change you're making is going to increase your cloud costs by this much. And it gives them a detailed breakdown of like, here's all the resources you're changing, adding, removing, and here's the cost impact of those. So, think about like a checkout screen for infrastructure. That's kind of what InfraCost does right now.
That's amazing. So just to clarify, let's say I'm a DevOps engineer. I have Terraform code, the most common infrastructure as code framework. Mm-hmm. And then I have a pull request in GitHub that I want to change some EC2 instance or some other types of resources. Before doing the risky merge, I will know much better what's going on.
Exactly. Like it will tell you, hey, you just increased the storage on this, or you did a new database, or you changed the instance type, you changed the region, the operating system, any of those variables has a cost impact, right? And it tells you these variables you've changed this is the impact to cost, either up or down, right? If you're trying to save money, it says here's how much you're going to save with this move. And the other thing I'll say is InfraCost is that part is free and open source. So why not? Like, why not have that safety net?
If I remember correctly, you already have like thousands of GitHub stars for your open source, right?
Yes. I think we're thousands and thousands of users, and I think 8,500 or 8,000 GitHub stars. I like those GitHub stars.
That's amazing. So you are trying to, if I may say, shift left the decisions way earlier in the pipeline.
I mean, like that's one thing that's super cool about infrastructure as code, right? The things if we look at the industry as a whole, we've seen security shift left, right? And we've got companies in the public market who are shifting those stuff left, but we still haven't shifted cloud cost left enough. We've tried to, like you do I'm going to look at the bill, digest it, and tell the team how much they've spent. That's not really shifting left. That's like still reactive and telling people what's happening. With InfraCost, we're actually trying to shift that left, have that actually in the workflow of the engineers.
I remember you talked about shifting left security. I had the honor of being one of the first consultants in a very successful company named Snyk that are shifting left security. And what you're doing for cost, they've been doing for security. So let's say I develop some code in Node.js and I starting to use an open source library, which is helpful, but I use a version of that which is risky and has some known vulnerabilities. In the pull request, I would get alerts about those risks, and that will help me prevent those mistakes before merging. And my question to you, if I remember correctly about Snyk, they took it one step ahead And they do that also in the IDE, meaning if I develop code, even before pushing that to GitHub to the pull request, it's not the same as the main branch. Pull request is much more isolated, but even a pull request creates some noise if it has some problems, some risks. Does InfraCost doing now or planning on doing shifting that left even more to the IDE? Is that on your radar?
How far left can we go? Okay, so we do. So we have a VS Code extension right now. Literally, as people type Terraform code, we say, hey, this thing you just typed is going to have this cost impact. It's going to be this much. And that really enables those what if scenarios to happen, right? The engineer's typing out, what if I did this block of code versus this block of code? Immediately get two cost estimates. All right, you get to see it. However, I'm going to push that further. The question for us kind of long-term also is how far left can you go? Because remember, at this point that the engineer's writing the code, we've gone past some architectural decisions already, right? So one of the open questions is, can we go further left and get into the architecture stage? And I think that would also be super interesting. Right now, it's where the infrastructure as code is enabling this, where we have the cost estimates and the pull requests and things like that. And I think it's very impactful for the engineers to see, because that's the point that they can make those changes of the cost. And then the architecture stage will be a rougher estimate, but I'll give them directionally how much it'll cost. Right. So I think that'll be helpful as well. But I'm going to turn this around now. What do you think? So the argument I've heard as well is, all right, how much stuff are you going to go shift left? And when can the engineers actually work on, like, if they're shifting left to everything, what are they going to do? Are they going to write code, or are you just going to look after all the others? What do you think about that?
Wow, that's a great question. I think the first thing I've noticed that is shifting left with the responsibility is performance. I remember New Relic and APM, other application performance monitoring tools. And for the first time, I remember us engineers taking ownership of your performance impact. Because before that, it was the operations responsibility. If something is slow, it's probably an infrastructure issue. And why should I care about the performance? Add more CPU, add more memory, I don't care about it. But obviously that mentality has changed, and those kind of developers can no longer be called senior developers or good developers in my honest opinion. But it wasn't really that shifting left. It left from operations to developers, but still it was reactive. After you deploy your code to production, maybe to staging, maybe you had APM like New Relic in staging, so you could have started monitoring that before it reaches production, but usually it was after it reaches production. So that was the first thing of more responsibility for the developers. Then I think things like security, obviously, whether it's open source or your actual code that has security vulnerabilities. I've seen some solutions about licenses. Maybe you're using an open source library that will work and be efficient and secure, but your company cannot really sell that as a commercial product because this license is pretty limited. So you need to be aware of that as well when you make those decisions. So I think all in all, the life of the developer, whether it's the DevOps engineer or the application developer, changes over time to have more responsibility together with more tools that allow that just throwing more responsibility without the appropriate tools and processes is not going to work. But I think gradually we see more and more responsibilities for the developers. And I think the revolution of infrastructure as code, when infrastructure is being represented as code and not physical hardware, not even virtual or cloud, it's code. It's not about changing directly cloud resources. It's first you need to change code. We are seeing the same concepts of shifting left to the developer. So I think, long story short, I think the trajectory is clear, more things are shifted left, but it needs to be done with cautious, the right tools, and the right processes.
100% agreed, right? I think that's like what I see as well. What I'm seeing is if you want to shift something left, it's fine to do it as long as you provide the support, the framework, and like the process in there, right? Where the engineer is still in their workflow and working efficiently, and at the right point, their process is appended with information that can help them make better decisions. I love what one of our users is actually from Wix says, right? It's like better engineering. This is better engineering. Like you're writing better code. Like it's more efficient. Okay, it saves more money as well. And that's a better code. It's more optimal. It's more efficient. So I agree. Yep. I think there's more to shift left. This just needs more tools and processes and help.
I think in general, the life of the developer is changing to use more blocks and pieces and glue those together. I remember I just celebrated 41. I had a birthday yesterday, so I'm a bit
happy birthday.
I feel a bit old sometimes. And I remember, I'm not sure if our audience knows about it, what eventually works in the CPU. I actually wrote assembler code 20 something years ago for an operating system called DOS by Microsoft. And that I had to develop a driver for DOS. Don't ask me why. And you need to do everything really specifically, but it's really inefficient. So today it's way more the big blocks, and the engineer needs to understand what can be done, and as a fixed piece that you can take it as is. You don't need to write assembly, you don't need to write a lot of complicated things. You can just use open source and other tools to help you optimize your work and focus on your core business. And it's beautiful to see this trajectory, this trend of how the developer's life is evolving. But let me go back to infrastructure as code and infra cost. So I have two very specific questions about that. We've mentioned Terraform, but Terraform is not the only framework out there. So two questions here. A, what do you think about the different frameworks and where it's going? I can mention Pulumi and Crossplane as other multi-cloud open source frameworks. I can mention the vendor specific, mostly CloudFormation for AWS or ARM templates for Azure. What do you think is happening today, and what do you think will happen in a few years with the variety of those frameworks? And the second question, which might be related to that, is what about infra costs? Will infra costs support several multi-frameworks, or will it focus mainly on Terraform?
Yeah, good question. Okay, so I remember back when kind of new services, AWS was launching, and we were like, all right, everything's going to shift to cloud immediately. And then serverless came out, and they're like, all right, everyone's going to serve serverless. And then Kubernetes, kind of the whole process. What I honestly think will happen is things will coexist. So the customers, the bigger customers I speak to, I ask them, are you Terraform? They're like, yes, but I also we have Azure Arm in there. And we're trying out Pulumi as well. So I think that's natural. And I think what's going to happen is the same thing that took a while to become multi-cloud. Remember, it wasn't multi-cloud before, but now it really is. I think the same thing is going to happen here. It'll be whatever tool for whatever team that helps them most, they'll adopt that, and it's optimized for that, and they'll use that. So I think there's massive space still to grow. There's a lot more applications coming onto cloud still, right? So I think all these IaCs will compete and grow. For infra cost, we have to support all of them. And that's one of the challenges we have, right? So we started with Terraform, and now we're getting a lot of requests for CloudFormation, for Pulumi, for Azure Arm and Bicep. And I think it'll just keep going. And I think one of our challenges, and probably what I would love to see what you think as well, is we have to keep the tooling that we provide, we have to keep supporting all the major providers, and that's the challenge in us as kind of suppliers. What do you think?
I think the same as you mentioned about the shift to multi-cloud. We see the same with the shift to multi-frameworks. Eventually, you have different teams that have the mandate to select their best technology. In both Terraform, CloudFormation, Pulumi, those are free. So there is no real friction there in order for somebody to decide, okay, this new project, this new group, we're going to use Pulumi, we're going to use CloudFormation, we're going to use Terraform, we're going to use TerraGrant. So we see more and more the variety. I do want to mention that Terraform is definitely the leader, and not just because of the being multi-cloud and open source, but also because of the ecosystem. If you look at other things that support Terraform, so two things here. One is the providers. Okay, so I'm not just using AWS, I'm using AWS and Okta and Auth0 and SendGrid and Datadog, everything I can manage with Terraform, whereas the support for that in CloudFormation or others is way more limited. And if I look at solutions like InfraCost that I want to do as part of my package of solutions, I want to have cost awareness. I want to use InfraCost. I want to use policy as code. So I want to use Open Policy Agent. I want to do some static code analysis. So I want to use TerraScan or TFSec. So all of those make it simpler decisions for me to choose Terraform. I think that's one of the biggest challenges for the other infrastructure as code frameworks, not just to support multi-cloud or to be efficient and developer friendly. It's more about the entire ecosystem for making those decisions. But as you mentioned earlier, you cannot stop the developers, and they will choose whatever makes sense for them for those scenarios. Like you have multi-cloud. I remember seeing like 5 years ago, the shift to Google GCP because of GKE. They were the first one to introduce the managed Kubernetes. So I've started seeing some AWS customers moving or adding also GCP, mainly because of GKE or BigQuery in that sense. Things that you have specifically in one technology, in one vendor, or in our case, one framework. So I think the multi-framework situation is inevitable. But I am a big believer in Terraform being the leader of those frameworks.
Yeah, I think that's a good point. Like, so when as tools or small projects, side projects, you want to test with something, then you basically can test with anything and learn anything, right? You do that. As you go towards production systems, I think more and more the bigger companies are looking at, okay, the ecosystem of support around it also. And I think that's spot on. They're like, okay, if I want to use CloudFormation, okay, it's AWS only. What does the ecosystem support that? And if there's not a lot of support, it's not the end of it. Like, it's not going to stop adoption, but it's going to add another question. It's like, are there going to be support for this? Are there going to be more tooling? And I think one of their challenges of each one of these kind of open source tools or providers, IaCs, is to encourage the ecosystem as well and work with the ecosystem to enable them to plug in their tools and support the growing community base as well. I think that's super important.
Awesome. Let's go back to InfraCost. So I've asked about multi-framework. I want to ask about usage-based costs. So EC2 virtual machine has fixed pricing, whether you really use it or not. As long as it's up and running, you're going to pay for that. However, Lambda function or a more common auto-scaling group Kubernetes cluster, RDS databases, those you pay according to your usage. What do you think about this more complicated problem, and what's the approach of InfraCost about that?
Yeah, okay, great question. And I'll expand it and make it a little bit more hard as well. But okay, so overall, if we think of cloud costs, they split into two different buckets, right? The fixed costs exactly as you said, EC2, things like that. Regardless if you use them or not, you're going to get charged that price, or that's going to incur that cost. So those are easier, still complicated, but easier to estimate and put in the engineering workflow. For those from InfraCost point of view, they get scanned, they show the end user, this is exactly what's going to happen. Usage-based resources are interesting because for usage, the first thing InfraCost does is scan the code and detect that there's a usage-based resource in here. So what it does is actually tell the end user, hey, the way this is priced is based on request and duration. And the components of these is, for example, 20 cents on every 100 requests or 10,000 requests. That's shown to the engineer immediately. So the engineer now knows at least what parameters are going to get charged for the usage-based resources. Then with InfraCost, also what we have is something called a usage file, in which you can model the usage that the usage-based resources will have. So, hey, I have 2 terabytes of S3. I have X data transfer coming in through. And so when you populate the usage file, those are then used to estimate the usage-based resources so that the engineer knows, okay, here's what we're going to roughly. So the majority of usage that I've seen on the usage-based resources is profiling. So you define a low usage profile, a medium usage profile, and high usage profile, so that the engineer can say, okay, I think this application is going to be a medium usage profile. And kind of use that as a cost estimation. Now, if I look a little bit further, I think what we have to do also is automate some of that, which is, can we connect to the cloud provider and per resource, pull down the last 30 days average of usage and use that as a basis of the cost estimation? And a good example of that would be, okay, I'll tell you how much S3 this bucket has data in it. What tiering do you want to use? If you change this tiering, here's the cost impact that's going to have on the usage that you've had in the last 30 days. And that's kind of one part of it. That's kind of the usage-based part of it. Now, if I make it more complicated, in fact, before I make it complicated, think of cloud costs as an equation, okay? That might help. So cloud costs equals usage multiplied by price. What a lot of companies usually do in this space is play around with the price component of that equation. What do I mean by that? I mean, they buy RIs, they go and negotiate with cloud providers, commitment discounts, EDPs, EAs, things like that. Now, they're all playing with the price component of that equation. So if it's 100% usage waste times that discount, yes, you're getting a discount, but it's on waste. And so you got to move, the engineers can impact the usage component of that equation, and finance with commitment discounts and negotiations can impact the pricing of that place. So you then have this complexity on top of it is, I'm going to launch a resource. Is it going to get an RI or not? Is should I look at the price with an RI discount or not with an RI discount? And so what InfraCost is trying to do more is help the engineer make that decision and then make that information available to the finance teams and say, hey, an engineer's launched something here, and they've said, they're communicating that this is going to be a long-term project running. You should look at buying RIs, or at least negotiating that price component of that equation. So long-winded answer, but this cost thing keeps getting more and more complicated. And I think that's why when we shift left, we've got to be very clear in the tooling to help the engineer, and then communicate that forward with others as well in the organization.
Awesome. I think I have last big question for you. Right. We're starting this year with clearly the markets are struggling way more than a year ago. Yeah. And it's quite known that the second biggest cost for organizations after payroll is cloud cost. We hear more and more DevOps engineers and teams more focused on reducing cloud costs. It was always in the top of the agenda, one of the main things in the agenda. So my first question here, you hear that more? Do you hear the awareness for reducing cloud cost becoming even more important because of how the markets are struggling in the way for efficiency and profitability? What do you see from when you talk to customers?
100%, 100%. So I see kind of two things happen. One, it's becoming more important for companies as a whole. Therefore, people within the organization have got to get involved with that. And the second component is, I think everyone realizes the main changes you can make to your cloud costs in terms of efficiency, not just reduction, but optimization. Remember, you're using this, right? So it's not just like reduce it, but it's optimize it. It comes down to the engineers. A lot of the work does come down to the engineers. So it's becoming more and more top of mind for the engineers. So I'm definitely seeing an uptake, and I'm definitely seeing more of a priority given to it across the board.
Another thing I've heard in that context, maybe it's total nonsense, but probably you can shed some light here. The FinOps teams, we more focused at NF0, we focus more on the DevOps teams, and you're probably more focused on the FinOps teams. And I've heard that there is a bit of a shift from those teams from reporting to the CFO to reporting to the CTO, because it's clear that the work is becoming more technical and less Excel and just numbers, more about, okay, we need to better understand what kind of decisions can be done. Are you seeing FinOps teams becoming more technical and maybe instead of reporting to CFO, reporting more to CTO, or is it not that relevant what I've heard?
That's a good question. So because of where I sit, and because being a CLI tool, being open source, adopted by platform teams, engineers, I see more of the FinOps teams having a technical kind of pedigree in them from the get-go. And I think it's important for kind of a cross-functional thing to happen, right? If you think of that equation again, both need to work. Like the price can be negotiated down and the engineers can reduce the usage of that. So I definitely see them more reporting to an engineering manager versus a finance side of the business. Now, the other thing I'm seeing, which is interesting as well, is product teams or product owners becoming involved in that as well. So if you think of engineers making code changes, all right, there's a reason they're making a code change. And it's usually because a product feature is requested, we're developing this and things like that. A super interesting feature we just built and released is the Jira integration. So a product owner opens a Jira ticket, says, I want this feature. All right, we've got 10, 20 pull requests. Can we sum all those costs up, send it to the Jira ticket and say, this Jira issue that you've opened and you want to add this feature consists of these infrastructure changes, and that's the cost impact. So the product, right, this feature that I'm building has a cost impact as well. And then that can be taken for budgeting within the FinOps group. So it's kind of like there's specialists in the FinOps group, but also there's people reporting in about what we can do and change there as well. So I think it's a pretty fast evolving space and team. And I think it's going to be pretty exciting to see what happens as we go through, especially this year and next year, with the cost reductions and things like that.
Awesome. Yeah, Hassan, I think every company really cares about cloud cost. And I think what you're doing in InfraCost is super interesting, together with the shift for infrastructure as code, that every piece of your infrastructure becomes a piece of code. And I really want to thank you for the session today. It's been really enlightening. And I hope our audience learned a lot from listening to you and our conversation. So thank you for joining this episode of the Infrastructure as Code podcast. I want to thank all of our listeners. Feel free to follow us on Twitter, the IaC Podcast, and share with your friends if you enjoy that. Thank you very much and have a great day.
Awesome. Cheers, folks. Thanks so much.
Thanks.